Okay, hello everyone. So another data analysis video, still focusing on data wrangling and processing data to get it into some sort of tidy uh, order so we can conduct different statistical analyses and computations on it. So what I'm going to do in this particular video is I'm going to demonstrate how to add labels to a categorical variable. And we often get data sets, or they may be saved on a spreadsheet, and we may have some sort of categorical label, categorical variable with different levels that have different names, and they may have been recorded just using kind of numerical values or dummy codes such as 0 and 1, or they may have been just recorded as some type of string object, and what we might want to do is actually add more meaningful labels to represent the levels or groups of that particular variable. So I'm going to demonstrate how to do that using Python and pandas and NumPy software libraries. And I'm going to use something called the map method. Okay, so first of all, I'm going to import pandas and NumPy. Mostly we're going to be needing pandas, but NumPy may be useful as well for some of the manipulations we need to do. So as usual, I'm importing pandas as PD and importing NumPy as NP. So I'm giving them those nicknames so that they're easier to work with. And I'm going to import a data frame. It's one that I've kind of used before as an example, and it's this fearofcrime.csv data file. So not entirely sure of the origin of it, but it's data from quite a few participants that records kind of how anxious they are about crime and various other variables. So what I'm going to do is import that fear of crime CSV spreadsheet that's saved in a folder on my computer. I'm going to import it as df, which is quite a common convention when you're using Python. So df as an abbreviation for data frame. And then I'm going to use the pd pandas.read underscore CSV fear of crime .csv is the actual data file that I want to import, and I'm passing that in as usual as a string object between single quotes. Could use double quotes, but I'm using single. So if I use the .head method, you can see there is the first 5 rows of this data. So we've got variables of sex, anxiety level, stress, some sort of stress score, some worry score, and then this last one construct is some sort of scale score on constructive thinking. And if you kind of remember from a previous video, if I run the df.info method on to get some information about the variables in this data set. So there are 235 entries, and it's showing 235 non-null entries for each of the variables. So it looks to us when we look at this like there are no actual missing values, but there are some missing values, and the data type is shown as an object. So they've all been imported as strings, even though a lot of these are kind of decimals or integers. Not quite sure why that is, but there are some things that I will do with this to sort of demonstrate. I'll show you some of the issues and how to kind of find them, identify them. But one of the first ones is they're all shown as string objects rather than floating point decimals or integers. That's not too much of an issue for what I'm going to do here, but it will kind of highlight the fact that the missing values have been hidden from us. So the thing that I'm interested in this particular video is adding categorical labels to or more meaningful labels to a categorical variable, and we've got 2 here. We've got sex and anxiety levels. So sex has 2 levels, I think 1 and 2 for male and female. Those are the levels, the categories, the groups for that variable. And anxiety level also happens to be a categorical variable, and the levels are in the data frame. You kind of see some of them here. You can't see them all. They're 1, 2, and 3. So I think 1 is a grouping variable for some people with low anxiety. 2 medium anxiety, 3 people with high anxiety. But interestingly, we think we have no missing variables. But if I check the number of unique values recorded for this anxiety level variable, and to do that, I'm basically just gonna use this dot unique method on that particular variable from the data frame. What you can see is it returns it returns like 4 values or levels. So we've got one group which is 2, and notice they are all strings. They're string objects. They're between these single quotes. We've got 3, which we expected. We've got group 1, and then we've got this 4th, which is just like this blank space. So it's basically an empty string. And what's happened here is where we've imported this data set and it has some missing values, and it's imported everything as a object data type. It's rather than representing this as NaN, not a number, or as a missing value, it's kind of just saved it as a string, essentially. So it looks like we actually have 3 categories for anxiety level. It looks like we have 4, and if we try to add labels to our categories, we get some sort of error because we'd only give it 3 labels. But as it currently is, Pandas is interpreting that there are actually 4 groups or categories. And if we look at sex as well, which is the other categorical variable, and we use the .unique method, we get the same sort of issue. So we've got one category, which is 2, which is saved as a string object. Category 1, so I think 2 may be female, 1 may be male in this particular data set. And then we've got this empty string again, so it thinks there are 3 categories for sex. So that's a bit of a problem, and what we want to do is get rid of, remove these from each of the categorical variables, angs, level, and sex. We want to remove these missing values, really. We kind of want to drop them, and there are a number of different ways we can do that. What I'm going to do is I'm going to create a new data frame object that only contains the observations, the participants from angs, level, and sex, whose values are not this empty string. Okay, so what I'm going to do is I'm going to create this. I'm going to call it data frame 2, and what I'm going to do is take the original data frame. I'm going to invoke this .loc method, and then in these square brackets afterwards, I'm going to pass a couple of parameters, a couple of arguments. I'm basically saying df2 is going to consist of all the rows from df whose angs level is not equal to this empty string, and it's also going to consist of all the rows whose sex is not equal to the empty string as well. So that's essentially what that means. I'm using this AND Boolean operator. Notice I've had to surround each expression in parentheses, but what I'm saying here is take the angs level variable from data frame, and this exclamation mark equals is basically saying take all the participants, all the rows that are not equal to this empty string, and from sex the same thing, take all the participants and rows that are not equal to the empty string. So what that should do is just return a data frame that contains only the angs level categories 1, 2, and 3, and only the sex values or categories 1 and 2. And if I run this df2.shape, it tells us now the size of the data frame. And previously our data frame was 235 entries, and we can see now this is rows and columns. We've still got 5 variables, we've still got 5 columns, but we've now got 227 rows in the data frame. What that's telling us essentially is it's dropped a load of rows, and it's dropped the ones the ones from sex and anxiety that were recorded as being this empty string object. Okay, so if we do .info now, what we can see is we've got this reduced data set with only 227 data entries, 227 participants. One thing to note though is we now only have 227 entries, but their index runs from 0 to 234. I'm not going to worry about that too much. The reason for this is it's retained the original index and just deleted the values that were empty strings. We could just reset the index. We could just call df2 dot reset index, and that will reset the index from 0 to 226 essentially, but we don't need to for this in this particular instance for any reason. Okay, so now let's check again then to see how many unique values we have for anxiety for the angs level variable. There should be only 3 if this has worked properly, and there we can see now it's dropped. The code that we used above has dropped that empty string, and the same for sex. We should just have 1 and 2. Okay, with that done, what it would be useful to do is the whole point of this video, which was to sort of map on add labels to these different numeric grouping levels for the different variables. So to do that, we're gonna use the .map method and pass it a dictionary. What I prefer to do is, when I add labels like this, I kind of create them as a new variable and append them onto the original data set. So what I'm doing here is I'm using data frame 2 and I'm creating this new variable called angs label. Okay, and it's gonna kind of match the angs level variable, but it's going to rather than showing 1, 2, and 3, it's going to show low, medium, and high. And to do that, what I'm doing is I'm taking the angs level data variable from the data frame 2, using the .map method, and I'm passing it this dictionary that you can see in the parentheses after .map. And remember, dictionaries are contained within these curly braces. They contain key value pairs. I've put these in as all as strings because they are string objects in the data frame at present. So what I'm doing is I've got a 1 between single quotes there, a colon, that's the key, and the value that is going to be attached to it is low. 2 is going to be medium, and 3 is going to be high. So what I'm doing here is creating this new variable, and I'm saying wherever there's a 1 for angs level, show the value low. Where there's a 2, show the value medium. And where there's a 3, show the value high, or the label high. Okay, and if I run that cell, get a little error message, but it has actually worked. And you can see there, so angs level 2, medium, angs level 3, high, angs level 1, low. Okay, and if I had run this code, and rather than creating a new kind of variable name, if I'd have just used angs level here, it would have basically changed it in place as it is. So 1s, 2s, and 3s, it would have just changed those to these string labels that we see here. I often think it's useful to kind of just append them as new variables, and then you can visually check to see if it has worked. And we can do the same thing with sex. So I'm going to create this, append this new variable to the data frame sex label, and we're going to take the sex variable, going to use the .map function. 1's going to be male and 2 is going to be female. That's the dictionary that we're passing to it. So we now, if I run that, we now have these more meaningful labels. So when we did some sort of analysis with this, if say we were comparing groups in some way, we'd be able to use these labels, and it would be much easier for us to see for us to understand in a meaningful way what the differences were between groups, rather than if we were just looking at ones, twos, and threes, or ones and twos. So we'd have to keep going back and looking up to see if to try and remind ourselves what those levels were. And you can see now if I run .info on this data frame, we've got these additional two new variables included. Okay, so I mean, there are additional things that could have been done here. I could have converted, we could have done what I did in a previous video and converted all these objects to numeric as they should be, but we didn't need to, just to kind of demonstrate this here. We may want these to be numeric, so we could use them as some sort of index or dummy code for when we're running analysis. But in this case, it's fine that they're objects, because I just wanted to demonstrate how you could add these labels. Okay.